It scares people to think about how much money they lose or the risk to life safety when power is lost at a facility. We have seen a large increase in the size and the scope of fuel systems as more and more functions of the building become critical. The first question for a client is typically, what needs to be protected and for how long?
The first step in determining the fuel volumes is to know the duration of emergency power required. This is set either by the Life Safety Code, a state regulation of facilities such as hospitals, or a management decision for operational security. Typical design durations are 8, 24, 48, 72, or 168-hour, 1-week durations. Next, you need to know the generator and boiler sizing and load, as well as the safety factors needed for the actual on-site usable quantity versus the design requirements. Use a rough estimate of 75 GPH or 1.25 GPM per 1,000 kilowatts for consumption at full load. Then multiply that by the total kilowatts of generator capacity and the required run duration. For example, for each 2,000 kilowatt generators with a 24-hour run requirement would be 4 gens times 2 times 1,000 kilowatts times 75 GPH times 24 hours, which is 14,400 gallons. We use a rough estimate of 100 GPH or 3.3 GPM per 1 million BTU, then multiply that by the total BTU of boiler capacity and the required run duration. For example, 3 million BTU boilers with a 24-hour run requirement would be 3 boilers times 3 times 1 million BTU times XX GPH times 24 hours. Base the fuel storage tank capacity on a safety factor of 1.33 times the calculated quantity, which is equivalent of the tank that is 75% full. This is because A, the tank can be filled only to 90% by most regulations to prevent overfills. B, the lowest 5 to 10% of fuel in the tank may be inaccessible to the pump and may contain water or sediment. And C, the fuel volume is likely reduced by required testing that has not been replenished by periodic refilling.